next we have Oscar on the topic of, okay, he's here. There you go. Thank you.
Okay, hi everyone. My name is Oscar, and today's a very special day for me. It is my birthday today. And you know, what will make me very happy is if at the count of 3, everyone shouts happy birthday as loud as you can, okay?
We can sing for you.
1, no singing, please. 1, 2, 3. Oh, you guys, you didn't have to do that. Please stop. Okay. All right, thank you, everyone. All right, let's get started. So, welcome to the I/O Connect. Very happy to be here. I'm here for mainly 3 reasons. Number 1, I want to talk about Gemma and the updates on the open models. I want to talk to you about the Responsible Generative AI Toolkit. And then lastly, I want to hear about what you're all doing regarding AI and how you're integrating AI in your applications. For that reason, I'm mindful that we're running just a little bit behind in time. I'm going to try to run a little bit fast here. I know we have a break right after. Please do come to talk to me. Again, I love to hear about what you're working on and what kind of things you're doing with AI. Okay, so to get started here, AI has been going on for quite some time now. You know, maybe the term was not as mainstream as it is now, but obviously from science fiction, it has been always in the back of our minds. Google has been leading the charge in AI for a very long time. It has been a core part of our company, and it is recently that has become core part of not just the company as from a technical standpoint, but simply as a whole. So there's a very abbreviated and selected history of some important events in the field of AI and some of the breakthroughs. The one that I always like to point out is in 2017, there's the Attention is All You Need paper. That was, pardon the pun, but transformative. That was the introduction of transformers. If any of you use ChatGPT, the T over there stands for transformers. It's all built on this technology that was invented at Google in 2017. Obviously, nowadays we have a myriad of different large language models and other kinds of foundation models. Many of them build on transformers. Some others do not. Some others are, for example, some of the vision models are diffusion models. But in any case, a lot of really interesting and exciting stuff happening. One of the core themes that I want to mention today is openness. It is really cool that we have a lot of companies out there that are building upon large language models and foundation models in general. I think it is great that we're building products and services around it. But as an engineer, I love the concept of open source software. And in a similar vein, I love the concept of open models. I do not want to live in a future where AI, at least especially the AI that works best, the best performing AI, is held in the hands of a handful of companies that have the resources and the capabilities to put that AI to use. We strongly believe at Google that AI needs to be for everyone. That's number 1. Number 2 is that we also need to meet people where they are. It is great that we make things open source, but if it takes you, a master's course to learn how to, grok our build system and figure it out, that's not good either. And then lastly, it needs to be built with a proven and trusted ecosystem. This is where the responsible AI piece comes into play. We'll talk about that in more detail later, but I think the gist of it is because AI is for everyone, it needs to be safe for everyone. So the main thing here is, again, here to talk about Gemma. It is a family of lightweight, state-of-the-art open models. They are, as of now, multimodal, but they started, of course, as text-to-text models. They are using the same technology behind the scenes as the Gemini models. Slight variations between training data and training methodology, but generally speaking, is the same technology underneath. Some of the key features that make Gemma different and unique and very interesting to me is that it is responsible by design. We spent a great deal of time ensuring that Gemma was trained and deployed in a way that we believe is responsible and, again, safe for everyone. It has a great performance given its size. We provide many different sizes for the models, and in many cases, they outperform much larger models. So that is great. Again, from a developer standpoint, an AI model is great, but it has to download half a terabyte on a machine. Then that's very difficult to work with. We want to have a range of things, a range of sizes, so you can have whatever fits for your application. It is very extensible and optimizable. That meaning that it is designed so you can run with GPU or TPU acceleration, and you can do things like fine-tuning it, for example. You can extend it to your specific use case. And lastly, and one of the reasons why I'm here, we want it to be community-driven. We want to make sure that the community is engaged and involved as part of the Gemma family of open models. So like I was saying, the idea is to meet developers where they are, and that means a myriad of different tool chains and platforms and all this giant ecosystem. And we have done what I think is a very difficult job of trying to release Gemma in many different platforms. Gemma from the start worked on, to name a few, TensorFlow, JAX, PyTorch. But then what happened is something amazing, is that within a few weeks of releasing Gemma, the community got to work. And now we have Gemma working in a lot more different places, including over 30 different integrations, which to me is just mind-blowing how overnight people are just spending all this time and resources in making Gemma and many other models work in their particular niche tool. We had over 10 million downloads as per the Kaggle stats. And then we have over 500 Kaggle spaces. This is a Kaggle thing. If you don't understand it, not a big deal, but the idea is that you can create your own inference time API in Kaggle, and it's hosted by Kaggle, relatively similar to the Hugging Face spaces. Some of the really cool things that the community has built, and I'm realizing now this is probably a little too small for you to read. Just to name a few, for example, we have the Gemma, which is the mixture of experts model. So somebody from the community decided to go and take a bunch of Gemma models and put them together and created a mixture of experts model. That's pretty cool stuff. You can do that because it's open source. You can just download it and do with it whatever you want. That's the whole point here. We want the community to do cool things. And let me tell you, anybody in this room could be featured in whatever next iteration we have of this presentation. Just build something cool and drop us a line. One thing to note too is that we are providing a lot of resources for academia and for students to get started with Gemma, and as well as all the other family of models that are available through Vertex that we just learned. The idea is that you can apply and you'll get a bunch of Google Cloud credits. I think that we just finished the first iteration of the applications. I think there were 1,080 applications, if I remember correctly, that were approved. And again, it's just Google Cloud credits. Why not? So the few things that I want to call out as part of what recently changed, and by the way, this is all as of last week, but as you probably already know, there were some updates last week. We will touch on that in just a second. But as of now, try to imagine that this presentation was given last week, and then we'll get to today. So as of last week, between the launch of Gemma, and then we have updated Gemma to 1.1. We also updated Code Gemma as well as Recurrent Gemma. Recurrent Gemma, if you are not super familiar with it, is a slightly different architecture. The idea is that transformers are fantastic, but the encoder-decoder architecture is very power hungry and very GPU intensive. So the idea is that we're trying to explore different ways in which we can implement some of these large language models that use less resources. Some of the literature seems to indicate that it is not as well performing, but maybe it is good enough, and maybe that works for your application. So you just never know. So what is new in the world of Gemma besides those minor 1.1 updates? Really cool one is PyLoGemma, and this goes back to, if you remember from a previous presentation, we're talking about multi-modality. PyLoGemma is a vision-to-text model. It is using a brand new model that basically converts any kind of image to some kind of embedding, and then we're going to use Gemma, the 2 billion parameter model, to convert that embedding back into text. This can be done. This can be used in a number of different applications. The main one, obviously, the obvious one is you can create some kind of image captioning. But one of the projects that I'm personally involved in, as one of my Google projects, is to, for example, use some of these large vision models in the context of clinical pathology. So we can look at, say, mammograph slides, and we can try to distinguish, build a classifier between cancer, non-cancer. And we are doing that using PyLoGemma. So again, it's a vision language model. It is built on Gemma 2 plus SIGLib. That is the model that converts an image into an embedding. It comes in different flavors, of course, just like the other types of models. But generally speaking, in the same vein as the other Gemma models, this is completely open source. You can take it and make it yours and use it for whatever you want. And again, if you're doing some cool stuff with it, please do let us know. Beyond being able to provide text from images, it also is able to do segmentation and object detection. So again, description is the obvious one, but we can do a lot of other different image and vision tasks. To the best of my knowledge, it is some of the state-of-the-art and best performing image model out there. I do not want to go over the entire set of benchmarks, and in fact, I was not able to fit all of them into the slide, but just to drive the point home, we have some pretty remarkable performance, and again, open source model, so please give it a try. And we have 2 different sizes of images, 224, that means that it's a 224 pixels by 224 pixels, or 448, double the size, or I guess 4 times the size. Some of the cool things that the community has been building using Gemma. Somebody else featured here. Like I said, you can also be featured here if you build some cool stuff, and just let us know about it. Yeah, we love to see the community being involved. Again, this is all about open source and community. So what is actually new? So that was last week. That's old stuff, man. We're here today, right? So as of 2 days ago, we announced Gemma 2. So we have Gemma 2 that outperforms much larger models. It delivers even faster inference across a number of different hardware. Again, it's been optimized for both GPU and TPU. Excuse me. And it provides, because of those 2 reasons, unmatched efficiency and cost savings. This is, once again, state-of-the-art stuff. This slide is relatively old, so please take the numbers with a grain of salt. To my understanding, this is as of May, when Gemma was still in the pre-training phase. The main thing that I want you to take away from this is to look at the size of those models. So if you look at Gemma 2, we are comparing a 27 billion parameter model to the 300 billion from Grok or the 70 billion from Llama. So it is less than half the size, and it has comparable or better performance. That is what's remarkable to me. Yes, sure, in the world of AI, bigger is better, but at the same time, we don't have an infinite amount of resources, and that's why we have a range of sizes, because different size model is gonna fit for a different kind of application. So I'm personally very excited to see that we are driving higher performance and higher efficiency in the smaller model space. We use the same tooling. That means that we have Gemma 2 in a number of different spaces and frameworks, like I mentioned earlier. It works on Keras, JAX, PyTorch, Transformers library, and many more, in some cases provided by the community. And we have given the documentation a do-over. Although I was taking a look earlier, and actually I did find a couple of issues, but we'll be taking care of that. Gemma 2 has been built for developers and researchers alike. It is, once again, open. I feel like I'm saying the word open a lot, but I want to make sure that you understand this is very important to us. It is open and accessible. It has a broad compatibility matrix in terms of frameworks. It is very easy to deploy, including, for example, in Model Garden, like we saw in the previous presentation. And it allows you to do some fine-tuning to your liking. You can use Gemma 2 in Google AI Studio, or you can just download it on your machine or on Colab or whatever you are using, whatever you're deploying your code. We have also released a Gemma cookbook. This is a collection of different ways in which you can use Gemma and different tasks that we know are common for Gemma. For example, how to do simple inference or how to do fine-tuning. You can find those in the cookbook. If you do like this stuff, by the way, please do start it on GitHub. That's a signal that we look internally to see what the engagement and interest is from the developer community, and that will allow us to justify further investments in those efforts. Obviously, I'm pretty confident it no longer has the 0 stars that I have here in my screenshot. So how do you use Gemma? The easiest way to get started is to go to ai.google.dev/Gemma, and you can see all of the pretty marketing page that my colleagues from marketing did. And it shows you all the key features and how you can get started in many different languages or platforms, whatever you're using. The other way is to go into Kaggle. Kaggle has, like I mentioned earlier, a number of spaces, but you can also just download the weights. You'll probably have to go into Kaggle anyway to accept the terms of service to download Gemma. But once you do that, you can download the weights, and then world's your oyster. Here's an example on how to use Gemma using the Google AI ecosystem, aka Keras, specifically the NLP package. It's literally 2 lines of code. The first one is going to download the model and load it into memory. And then the second one is going to take the prompt that we have here, provide a maximum length, and out comes the output. This is as simple as it gets. Here's another example for how you can use Keras to fine-tune your model. So you enable LoRa. Who here knows what LoRa is? See hands. Okay, not that many hands. So LoRa is a technique that was actually invented at, I think it was Microsoft Research. And the idea is that you are able to do low rank, I forget what it stands for, low rank parameter efficient tuning. Anyway, you're able to do highly efficient fine tuning in a way that instead of having to change all 8, 9, 27 billion parameters of your model, you're only changing a small subset of them and still having similar performance. Obviously not the same, it's marginally smaller, marginally worse performance, but with a fraction of the computing power needed. To give you an example, you're able to fine tune Gemma, the 2 billion parameter model, in under 30 minutes using the free resources of Colab. That's remarkable if you've ever dealt with any kind of fine-tuning of or transfer learning of any of the other machine learning models. So you simply do the .fit to do the fine-tuning, then you save the weights into an H5 file, and then you can just load the weights. Again, just a handful of lines of code. Not shown here is your data set that you're fine-tuning with. We have, obviously, the abundant documentation, including a code lab that you can follow through on an example of how you can do fine-tuning. And now we're going to do a live demo because I am feeling lucky today. You should see my screen now. I'm going to go to AI Studio. And I think that's hopefully big enough for you to see. And what you're going to do in AI Studio, you go to aistudio.google.com. This is, again, completely free. All you need is a Google account, log in, and off you go. You choose in the list of models, Gemma 2. I think the only one that's available right now is the $27 billion parameter. Sorry, 27 billion parameter. And you can just ask the model whatever you want. We can say, for example, what's the capital of France? And that's it. You're using Gemma 2 under the hood, okay? Very simple stuff. But now for some extra points, we're gonna do some local runs of Gemma 2, and this is where things may get a little dicey. Wish me luck. We're gonna turn off the Wi-Fi right here, just to show you that I'm playing no tricks on you. And we're gonna go right here, we're gonna open a new one, and let's see, no Wi-Fi. Okay, so we don't have any connectivity. I have installed Gemma CPP. To run Gemma CPP, all you have to do is, number one, download the weights from Kaggle. And then number two, you clone the GitHub repo, and then you run make. Pretty simple stuff. As the name implies, CPP is native code. It is not going to be hardware accelerated, but it is going to work offline on your machine. So I have pre-run this command. All I'm doing here is calling the .gemma binary that I have just compiled. By the way, the compilation, it took, I don't know, maybe a minute on my machine. And what I have here, see if I can show you my Mac, is the 2021 version. I guess at this point it's basically ancient. So you're running the Gemma command, and I'm passing just the path to the stuff that I have downloaded. I downloaded the 9 billion parameter version, which was approximately, I think it was 8 gigs compressed, if I remember correctly. So we run it, and again, no internet. I can type, what's the capital of France? Make it a little bit bigger. And that is Gemma 2 running locally on my machine. If we try to ask it to type something a little bit longer, you'll see how it is not super fast. So let's see. Write an essay about the Napoleonic Wars. And you can see how it's basically outputting one token at a time. And you can actually see what a token is because you can see it coming, word, period, colon, and so forth. Yeah, backup failed because I have no Wi-Fi. You can see that it is running locally and on CPU because if I switch to this other tab, all my CPUs are being basically completely maxed. Running all my CPUs on my device, running pretty slow right now. So again, locally, but on CPU. Now, what's really interesting about some of these Mac computers, and this is not an Apple advertisement, but if you know anything about the new chipsets, I just stopped it, by the way, manually, is that they have integrated memory. So actually, whatever RAM is available on a machine is also available to the integrated hardware accelerator. Even though Gemma CPP is native only and does not run accelerated, there's another project that you heard about today that does run in hardware acceleration, and that is Ollama. So I have here, in this other tab, we can run Ollama run Gemma 2. Again, as simple as that. I have already pre-downloaded Gemma 2. That was, again, 8 some gigs. So I won't do that in this Wi-Fi. And once it loads the model, we can ask again, what's the capital of France? Ooh, that feels much faster. Let's try the essay one. Write an essay about the Napoleonic Wars. I even have a little misspelling there. Let's see if we can handle it. There it goes, super fast. Okay, and again, this is running locally on my machine, completely offline. Really cool stuff. Please do try it. This is, in my opinion, one of the coolest ways to get started with Gemma, especially now that the 9 billion parameter models and bigger do not run on the standard versions of Google Colab. That was typically my go-to. You go to colab.google.com or colab.research.google.com, get it started. That was pretty easy. Unfortunately now, because the models are getting bigger and bigger, it no longer runs on the free instance of Google Colab. You need one of the high memory versions. And I say, screw that, I'm just gonna run it locally. So I can actually run it without Wi-Fi. So right now, this would be my recommended approach. If you wanna get started with some of the large language models, use some of these open source tooling like Ollama or Gemma CPP, and just run in your machine. Pretty cool stuff. And now we can switch back to the presentation. Okay, so that was our friend Gemma. The next thing I want to talk about is responsible AI. I'm not going to talk about the fundamentals of it, but specifically I want to talk about the Responsible Generative AI Toolkit that we provide alongside Gemma. So once again, to rehash, Gemma's approach to responsible AI is that it is safe by design. It is also transparent, both in the sense that, well, it is open source, you can just go look at it, but we also provide transparency in terms of the evaluations that we perform. We released a very comprehensive model card that came with Gemma, and guess who wrote that model card? Okay, so if you have any questions about the model card, please do let me know. The idea is, again, to provide transparency regarding how Gemma was trained, how it was built, how it is deployed, and how you can use it. And then once again, alongside with Gemma, we released the Responsible Generative AI Toolkit. The main things that are part of the Responsible Generative AI Toolkit, and hopefully that's the last thing I have to say there, all those words together, is these 4 components, and I want to discuss them separately, very briefly, because I'm mindful that we're running short on time, and I want to make sure we have plenty of room for questions. And then during the break, please do approach me and tell me about how you're using AI. We have the Responsible AI Guidance. We call it RAI in the field for short. And we have a collection of documentation that you can read through. Think of it as Responsible AI 101. It is both for developers and non-technical people alike. We've done plenty of user research, and we have done many iterations on this guidance. I think it's pretty good. Please take a look. We also have a tool for model debugging. The tool is called LIT, and we actually have written a code lab on how you can get started with LIT. The URL is right here on the bottom. And the idea is that we can do, with tools like LIT, actual engineering when it comes to prompt engineering, because in many cases we talk about prompt engineering, but let's be honest, it is more of an art than a science. You try something, it doesn't work, you tweak it a little bit, still doesn't work, you tweak it again, oh, now it works, great, I'm done. We are trying to bring it more towards the science line of things, because using LIT, you can do a thing called saliency methods.